Hello, my lovely students. How are you, my boys? How are you, my girls? Hope you're fine. Today we're going to take the third lesson in chapter 8, which is the last lesson in our book and the last lesson in our semester. So I want you to open your book and open your mind and be ready with teacher Rima. Our lesson is, what is another way to change matter? What is another way to change matter? We took the first way to change matter, which is physical changes, right? Today we're gonna to take the second way. Our objective, students will be able to recognize that a chemical change happens when matter changes and becomes a new kind of matter. So chemical change happens when matter changes and becomes a new kind of matter. We said we have two ways to change matters. The first way is physical changes. Physical changes happen when we change matter, but we don't change what it's made of. Matter stays matter. Matter stays matter. We don't have a new matter. The second way is chemical changes. Chemical changes. This is our lesson. Chemical changes happen when we change the matter to make a new matter. We're gonna to change the matter to make a new one. Okay? Here. Matter stays matter. Okay? But in the chemical changes, matter changes to new matter. Okay? Here matter stays matter. So we have the first matter and stays the same. Here matter, the first matter is changed to have a new matter. So new matter is created. Okay? We talk also examples of physical changes and chemical changes. Let's see the first one, which is physical change. We will see examples of physical change like cutting, evaporation, condensation, mixture, freezing, and melting, right? We talk them all. Now, examples of chemical change like burning, rusting, cooking, baking, adding vinegar to baking soda, and firework. Here we have pencil, and the pencil is broken. Okay, but the pencil stays pencil, right? Here we have pattern, and the pattern is melted. Okay, we have ice, which is water, and the ice is melted too. But water stays water. Pattern stays pattern. Pencil stays pencil, right? Matter stays the same matter. But here we have wood, and we burn this wood. We have now a new matter, which is ash. We have ingredients. We mix the ingredients together and we have a new matter, which is cake. We have raw egg and we cooked this egg. Look, here, cooked egg. The cooked egg is different than the raw egg, right? So here we have new matters, but here matters stay the same. But what do you mean by chemical change? Chemical change happens when matter changes and becomes a new kind of matter. Let's sing it as a song. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Do you save it? Let's try it together. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Let's try to write chemical. 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 Chemical change. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when some matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Let's try it. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Do you save it? I hope so. Chemical change happens when matter changes and becomes a new kind of matter. Good job! So, to know more about the chemical change, you have to know that you cannot change matter back again into the first matter. You cannot change matter back into the first matter. So, you cannot change the ash back into wood. You cannot change the cake back into its ingredients, right? And the egg too. So you cannot change matter back again into the first matter. You cannot. Okay? I want you to see this video and We will study the ways to change matters, okay?
Are or what you are doing. Things, no matter where you are or what you are doing, things are changing all around you.
Things are changing all around you and all the time, okay?
Whether it's plants growing or logs burning, or even if you're just eating food, the materials around you are changing in size, shape, and structure, releasing or absorbing energy.
The materials are changing in size, shape, texture, releasing or absorbing energy. Okay, boys and girls? So, matters are changing all the time.
And creating new substances. In chemistry, most changes are divided into two categories: physical changes and chemical changes.
So, we have two ways to change matters: physical changes and chemical changes. Physical and chemical.
A physical change is something that changes the physical properties of an object or substance, like size, shape, or form.
Physical change happens when something changes, but the kind of matter stays the same. So maybe we can change the size or shape or form of the matter, but matter stays matter.
Cutting a piece of cloth is an example of a physical change.
So this is cutting. Cutting is example of physical change.
Even though the cloth changes shape and size when it is cut, it does not create a new substance. It's still
So matter stays matter. The cloth.
cloth. Even if the pieces of cloth are sewn together and made into a shirt, only physical changes have occurred. The shirt
So even if the pieces of a cloth are sewn and we made a new t-shirt, it's made of cloth and it stays cloth.
is still made of the same substance as the original cloth, just in a new form. Another type of physical change involves changing states of matter, and water is a great example of this.
Changing a state of matter. Changing states of matter. We have freezing, evaporation, melting, and condensation. So let's see the water.
Ice melts and becomes water.
Ice melts and becomes water. Okay? Melting. This process is melting. And this is example of physical change.
And water evaporates to become steam.
Water evaporates to become steam. And this is evaporation.
But no matter its form, the water is still water. One way we can tell this is a physical change is that the change can be undone. Water vapor can condense back into liquid water.
So water vapor can condense into water. So this process, we called it condensation.
And liquid water can be frozen back into ice.
Liquid water changes into ice, and this is a freezing. This process is freezing. So in all of these processes, water stays water
Without changing to a different substance. In fact, many physical changes can be undone. For example, we know that dissolving sugar into water is a physical change, because even though the sugar and the water are mixed together,
so here we have water and salt or sugar. This is, we called it solution. Do you remember?
they do not combine and create a new substance. They are still just sugar and water.
They still sugar and water. This is solution, right? And we can separate the solution by evaporation, right?
And they can be separated from each other. Not all mixtures are as simple to separate as sugar and water. When you mix butter, sugar, flour, and eggs,
Here we have a new mixture, but focus in this mixture, please. Okay?
there is not a practical way to separate them again, but it is still only a physical change. The chemical change occurs when you put your mixture in the oven and add heat.
Again.
Mixtures are as simple to separate as sugar and water. When you mix butter, sugar,
Butter, sugar, flour, and eggs. Okay?
flour, and eggs, there is not a practical way to separate them again.
Maybe we don't have a practical way to separate them. Okay? But they still physical change. Okay? But focus now.
But it is still only a physical change. The chemical change occurs when you put your mixture in the oven and add heat.
When we add heat to the previous mixture, look what will happen.
Baking has many of the indications of a chemical change. The mixture in the oven absorbs heat. It also changes color and produces an odor.
Change color, reduce odors, and create or maybe absorb energy, right? New things.
Gases are released, which is what helps the baked goods to rise. Finally, this change cannot be undone. You can't unbake a cake. Chemical changes occur when the particles of two or more substances are rearranged to form a new substance.
Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when something changes and become a new kind of matter.
For example, when you burn wood, the wood is transformed into a new substance, ash.
Ash. When we burn wood, we have a new substance. New matter is created, which is ash. But we cannot return the ash back into wood, right? If I burn wood, we will have ash. We will have a new substance. A new matter is created. And we cannot return the ash back into wood. This is the chemical change. Chemical change, we have a new matter and we cannot return this matter back into the first matter. Okay?
Just like in baking, this change cannot be undone. Also like the cookies, the wood changes color.
But I wanted to show
Just
you.
like in baking, this change can
We change the color. We produce odor. You can smell the smoke, right? And maybe we create sound like this is chemical change.
cannot be undone. Also like the cookies, the wood changes color, releases gases, smoke, and produces an odor. Unlike in baking, this chemical change releases heat and gives off light. Chemical changes take place all around us. Metal rusting,
metal rusting, okay?
fireworks exploding,
Fireworks exploding, okay?
fruit ripening,
Fruit ripening, okay?
and digesting food are all
Also digesting food. When you digest the food, this is chemical change. And all of these examples are chemical changes, okay? Because we have a new matter. New matter is created.
examples of chemical changes. Here are some clues to look at if you're not sure whether something is a chemical or physical change. Chemical changes always form a new substance.
Always forms a new substance, a new matter. Matter becomes a new matter.
They may absorb or release heat.
Absorb or release heat. Needs heat or release heat.
Sometimes a chemical change will cause a change in color,
We have changing in color, producing odors, creating sound sometimes, okay? Releasing gas or producing light, okay?
produce an odor, create a sound, release gases, or produce light. Chemical changes usually cannot be undone.
Cannot be undone. That means we cannot return it back into the first matter. We cannot return it back into the first matter.
Physical changes do not form a new substance. A physical
Do not form a new substance. Matter stays matter.
change may change the shape or size of an object. It may change the state of a substance's matter.
We can change the shape or the size of object, and we can change the state of matter by the four processes.
Many physical changes can be undone in some way. In a physical change, you end up with the same substance you started with.
So we end up with the same matter which we started before, okay?
Even if it looks different. I hope you enjoyed learning about physical and chemical.
Look, here we have a new matter, new color, new odors, okay? So hope you understood the difference between the chemical and the physical changes. Okay. Okay. Bring your highlighter. Another kind of change to matter is a chemical change. Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. Burning, cooking, baking, and rusting are chemical changes. These are examples of chemical changes: burning, cooking, baking, and rusting. Burning. Burning is a chemical change. Look, We are burning paper. Look, if I burn paper, we will have ash. The ash is the black color. We cannot return the ash pack into paper. Caulking also is a chemical change. We have a new odors, a new matter, many things, okay? Baking also. And the last one, rusting. We will talk about all of them, okay? Here, write two examples of chemical change. You can write the four and you can choose two of them. So we will write caulking. If you wanted to write from here, or you can write firework. Firework is chemical change because we have a new matter. We change the color, produce odors, create sounds too. So firework is chemical change. What do you mean by chemical change? Chemical change happens when matter changes and becomes a new kind of matter. We will talk now about the burning. Burning is example of chemical change. Chemical change happens when something changes and becomes a new kind of matter. Chemical change happens when something changes or matter changes and becomes a new kind of matter. Burn. When wood burns, it turns to ash. So we have wood and the wood. Ash is created. Wood turns into ash. Look, ash, the black color. The wood is different than the ash. The ash is a new matter. Look here. When paper burns, it turns to ash. Paper, we have paper. That's right, paper. We add fire or we add heat. So paper burns, right? The paper burns, so it turns to ash. Ash is a new matter, so ash is created, right? And the ash is different than the paper. The texture of the ash is different than the texture of paper. The color of the ash, black, is different than the color of the paper. The smell also. The others here is different than the other here. So the color, the shape, and we cannot return the ash back into paper. This is the big idea here. We can't or you can't change ash pack again. So it's chemical change. So burning is chemical change. And bring your highlighter. Okay. Burning matter. Can you change ash back into wood? You'll answer me. Can you? No. No. We can't. When wood burns, it changes to ash. So, matter doesn't stay the same matter. Matter. Here we have wood. And ash is created. I have to change the color. So matter doesn't stay the same matter. Matter changes to new matter. Ash is a new matter. This is what you have to know it. Okay? Again, your highlighter. Okay. Ash is a new kind of matter. Okay. So ash is a new kind of matter. Ash has different properties from the wood. Sure. Ash has different properties from the wood. It was before a chemical change has happened. Look, here the ash and here is the wood. Okay? Different color, different shape, other, different texture, and we said color, shape, odor, and texture too. Many things. We produce odors. We produce light. Look. If you are in the dark, the ash will give us light, right? So we produce light. We produce odors. We have a new shape and a new color and a new also texture. Okay? A chemical change happens when wood burns. Okay? When paper, now the paper. When paper burns, it also changes to ash. So ash is created. You cannot change ash back into paper. We can't, because it's chemical change. Not like the ice. When I melt the icy cube, okay, I can return it back into ice. I have melted water and I can return the melted water into ice by putting the melted water in the freezer, right? But here we cannot return the ash into paper. We produce odor, we produce, we change the color, we change the shape, we change the texture. So we have a new matter, which is ash. Cause and effect. What is the effect of burning a piece of wood? You have to answer me. I guess this is an easy question. What is the effect of burning a piece of wood? Would, you can write here. Wood becomes what? I wrote it, Ras. Becomes ash. So ash is a new matter, right? Wood, you can write here changes. So wood changes to ash. What is the effect of burning? So a new matter is created. You can write also new matter is created. What is the new matter? Gotcha. This is C, by the way. I have to fix it, maybe. I didn't fix these letters because I guess you know them. Because I wrote them many times. Created. So ash is created or new matter is created. So this is chemical change. What is the effect of burning a piece of wood? Okay, ash is created and we cannot return the ash back into what? To wood or into paper. Okay. Caulking. The second example of chemical change is caulking. Caulking. Here we have raw eggs, okay? I guess all of you know the raw eggs. If you cook the eggs, it will happen. Chemical change or physical change? What do you think? Cooked eggs or cooked egg is different or cooked eggs are different from raw eggs, okay? Why? Why it's different? Can you tell me? I will show you. This is a picture of raw eggs. If I take one and I cook it. Look here. This is boiled egg. The boiled egg is different than the raw egg. Look, the texture. If you touch this one and touch this one, the texture here is different than the texture in the raw egg. The smell. The odor here is different than the odor here. We have another thing too. The color. Here we have white color, white egg. But here we don't have, only we have yellow, and this one is uncolored, right? So here, this egg is different than this one, and we cannot return the boiled egg into raw egg. This is the big idea. We cannot return the boiled egg into raw egg. Look here. Here we have fried egg. Do you like the fried egg more or the boiled egg? Both are yummy. So here, look at the fried egg. Here we have the texture is different in the white egg and also here. Here, the others are different here. The other is different than the other in the fried egg. What else? Color, texture, and the smell. So cooked eggs are different than raw eggs. here the fried eggs or the fried egg here, we cannot return it back into raw egg. So it's chemical change. Cooked egg is different from raw egg. Yes, they are different in color, in shape, in texture, smell, okay? And the big idea, which is we cannot return the boiled egg back into raw egg, and we cannot return the fried egg back into raw egg. Here we have raw meat and cooked meat. Look, what is the difference between the raw meat, this is raw, and this is cooked? The color, they are different color. And the texture, this one is smooth and you can make many shapes, but this one, it will have the same shape. We cannot change the shape, right? If you press on it, you can change the shape, but here you can't. Type. We have different colors, different shapes. No, the same shapes, because this is circle and this is circle, but different sizes, right? Look, the raw meat here is bigger than the cooked meat. Ask your mommy. Ask her, when you cook the meat will become smaller, okay? So different color, different shape, or different color, different texture, different size, and also we have the smell. Here, the other here is different than the other here. Here we have some clues of chemical changes. Different colors, smell, taste, shape, and size. Maybe we will have all of them in the same matter, in the new matter. Or maybe we'll have some of them. Maybe we'll have only different color and different smell, different color and different texture, okay? Or maybe we can have them all. So these are the clues of chemical changes. You have different new matter, and this matter has different color, different smell, different texture, different taste, different shape, and different size. You have to know this is chemical change. Look here, they have different taste. Let's see. And here also. This is different than the boiled, and the raw is different than the fried, right? Size, yes, we have different sizes. We have different sizes. Let's see. Sorry. Shape, here the same shape, but here different shapes. Taste, sure, we have different shape. Taste, here the texture, they are different. The smell also, and the color. So these are the clues of chemical changes. Okay. Thank you for your listening. Have a great day. Please study well. Please listen to the video. And I love you all. Thanks a lot. And teacher Rima loves you all. Remember the song of chemical change, okay? Chemical change happens when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. I want you to save it. I love you all. Bye bye. Sorry, I don't know.